Hi everyone, we're back for solving our problems that are a mix of exponential and logarithmic equations. So we covered a different example in the last video. Let me show you. So we were just solving this problem here, if you remember. We're going to do one that is slightly different in terms of like the way we solve it, although when you look at it like that, it kind of looks like it has the same pattern of having logs in the exponents and whatever. So without further ado, let's get started. Our first step is always the same. I hope you know by now that we're going to go ahead and do our domain. So our domain, looking at the bases, so in this case, we have base 25 for each of the logs, which obviously is a number and doesn't need us to do anything about it. So we're going to have to go ahead and look at our arguments. So again, we have two different logs, therefore two different arguments. So the first one is x plus 1 squared, x plus 1 squared. So if you remember, you need to find out when this is bigger than 0. Since you have a square, this is always bigger than 0. So for all x, we're going to go ahead and look for a second one. So for a second one, it's just x plus 1. No need for brackets. So x plus 1 is going to be bigger than 0, meaning that x is going to be bigger than minus 1. That's our domain. So that's going to be our the thing we need to be careful with at the end of this problem. So let's go ahead and solve this problem now. We're going to look at it a little bit before I start writing anything. So looking at this guy, the first problem, we had different bases for the exponential. So when we did this one here, we had 6 on one side, 1/2 on the other side. In this case, and then the other thing that I want you to notice is we had matching bases for the log and the exponential. So we had base 6 and then base 1/6, which became later on a base 6. But here, if I look at the base versus the base of the exponential, which is 9, and then the base of the log, which is 25, they're different. So we're not going to be able to use the same trick as we did before. However, what's interesting is the fact that we do have the same base here and here. One of the problems, however, is the fact that we have this annoying +3 in front at the end of this, the expression on the left side. So yeah, that might be a problem. It's not going to be a huge problem. It just means that we're going to have to use a substitution. Definitely, this is going to become a quadratic later on. So what should we do? So looking at this, like I said, what we've noticed is the fact that we have 9 and 9, but not only do we have that, we also have the same exponent except for the square here, which is a problem. But yes and no, because remember, whenever we're using substitution, one of them is going to end up squared. So one thing that I want to point out before I start writing anything is we can transform the left side a little bit so that it looks a little bit different. So I did it already because I don't want to waste too much time with that. But here, if you look, so this is what we have on the left side for the 9 to the power of log base 25 x plus 1 squared. So the first thing that you can look for is the fact that this exponent here, that our 2, I don't know what I'm on, our power of 2, you can bring it to the front of the log right here, as I did there, using the exponent on, not on base, on argument property. And once you have done that, this 2 can go back and be completely outside. So this one here was an exponent on the argument. Here it's an exponent on the entire 9 to the power of log base 25. And you can do that because you know that if you have two things multiplied in an exponent, you can rewrite it using this. That was one of our properties for exponential. So the fact that we can write it like this is going to be very helpful. So let me just use this result directly here. I think I want to zoom a little bit. All right, so we said that this is now 9 to the power of log base 25 x plus 1, and this entire thing is squared. So notice how the 2 seems like it's in the same position, but the brackets indicate that they're on the entire 9 to the power of log rather than just on the x plus 1. Plus 3 still there equals to 4 times 9 to the power of log base 25 of x plus 1. All right, so now we have the same thing here than here. I want a bigger, let's use a different color. Okay, so this and this here, same thing. So let's substitute, shall we, so that this expression becomes simpler. So what are we going to substitute with? Let's do t, because we like t. 9 to the power of log base 25 of x plus 1. All right, so this is what we're going to substitute with. Now, what are the possible values of t? Since we have a 9 to a power of something, remember that any positive base to any power is always positive. So the only possible values of t are going to be bigger than 0 here. We didn't have this restriction when it was only log, if you remember. All right, so this is t squared plus 3 equals 4t. Let's rearrange. Now you can solve for it. You can do the discriminant if you want. If you do the discriminant, you should get two potential values of t. So you should have 1 and you should have 3. Given that, we're going to go ahead and substitute back. So we had 9 to the power of log base 25 of x plus 1. And that's equal to 1. 1 is the same as 9 to the power of 0. So it means that log base 25 of x plus 1 equals 0. Let's rearrange that using our definition of log. So we get 25 to the power of 0 equals to x plus 1. I don't need brackets. Okay, so 25 to the power of 0 is just 1. So 1 is equal to x plus 1. So x is equal to 0. All right. That would be our first answer right here. So let's check to see if it's in the domain before I go to the other one. Our domain was x greater than minus 1. So yes, it is. So this is going to be our first answer. Let's go solve for the other one now for t equals to 3. So 9 to the power of log base 25 x plus 1 equals 3. 3 is same as 9 to the power of 1/2. Meaning that log base 25 of x plus 1 is going to be equal to 1/2. Now using the definition of log, we're going to rearrange that. So 25 to the power of 1/2 is equal to x plus 1. 25 to the power of 1/2 is simply 5. So x plus 1 equals 5 or x equals 4. This one is also inside the domain, meaning that it's an answer for us. All right, that's it. We've solved the second problem. Good job. Let me know if you have any questions.